So today's lesson is going to be on molarity. Molarity is a big, fancy scientific word for concentration. So when we talk about the concentration of something, that is the molarity. And the molarity, M, big M, is equal to moles over liters, where big M is the molarity or concentration, moles of solute divided by liters of solvent. So let's look at example number 1. And before we do so, keep in mind this has real life purposes. Every time you guys do a lab and you are given something that is aqueous, the overwhelming majority of those aqueous substances that you've been using in the lab, I have physically made myself using the concept of molarity and the calculations that we are about to do. All right, so I have to understand molarity in order to make up the solutions that you guys are going to use. Okay, so what is the concentration of a solution that has 0.4 moles of sodium chloride in a 6-liter solution? So we are going to take our moles of sodium chloride, 0.4, and divide that by our volume in liters, 6 liters. And when we plug that into our calculator, we get 0.067 molar. So how many moles of sodium oxalate are there in a 1.05 molar solution that has a volume of 300 milliliters? All right, this is milliliters. My formula is in liters. So step 1, we have to take our milliliters and convert it into liters. All right, so 0.3 liters is what we're going to be using. And if you need some help on that conversion, you may wish to go back and watch my video on metric conversions. So my formula is molarity, which in this case is 1.05, equals moles, that's what we're solving for, over my volume, which we have determined is 0.3 liters. So when I plug this into my calculator and solve for the mole, that is going to give me 0.315 molar. What is the volume of the solution that has 5.5 moles of potassium oxide and a concentration of 8 molar? So now we're looking for volume. So my molarity is 8. I have 5.5 moles. And we are looking for volume. So when we plug this into our calculator and we solve for volume, we get 0.69 liters. Now my problem did not ask me to solve in milliliters, so I'm going to leave it as is. Don't do extra steps and extra conversions unless you are asked to. That leads you to have potential accidental error, all right, with a question, all right? Because if you were to convert that incorrectly by mistake, then you would end up getting the problem wrong. So because I was just asked for volume and I wasn't asked what unit to put the volume in, I'm going to leave it as is. All right. A 3.24 molar solution of lithium fluoride with a volume of 100 milliliters is prepared. How many grams of lithium fluoride were added? So this is what I do when I'm making up your solutions. I say, what concentration do my students need? And how much of that solution do I need to make? And then I have to do the math to find the grams that are needed. All right, so step 1. We are going to take our 3.24 molar and we are going to solve for moles that I need. 100 milliliters is 0.1 liters. So I find that I need 0.324 moles of lithium fluoride. Now it's important that I know how to write the formula here because I'm asked for grams. Remember, in the lab, we don't have a way to measure the mole, but we do have a balance that measures grams. So I have to solve for mole, and then I can convert it into grams, where 1 mole is the molar mass of lithium fluoride, and I find that to be 25.941. So when I solve for this, I get 8.40 grams. So this is what I would physically have to measure out on the balance. If you are unsure of how I went from mole to gram and what molar mass is, you may wish to go back and watch my video on molar mass and my video on introduction to chemical calculations. All right, so how am I going to actually make this solution? First, I am going to dissolve 8.4 grams of lithium fluoride. And I'm going to dissolve that in distilled water. And I want a small amount of distilled water. I am then going to transfer this to a volumetric flask. And I'm going to add water up to the, in this case, 100 mil mark. I will not necessarily add 100 milliliters of water. I'm adding up to, all right? And because of intermolecular forces and the way things sometimes dissolve, volumes are not always what we call additive, where 20 milliliters plus 40 milliliters equals 60. 20 plus 40 may equal 58. It may equal 62. It doesn't always add up because of the intermolecular forces and those attractions between the ions in that solution and the polar water. So we will dilute up to the 100 mil mark. Very important, guys. Very important concept. All right, final question. 2.5 grams of sodium hydroxide was added to 100 milliliters of water, and the final volume of the solution was 98. So here's an example where I'm telling you that the volume was not additive. All right, so you will make the assumption that volumes are additive unless I tell you otherwise. And in this case, I'm telling you the final volume was not 100, it was 98. So what is the concentration of the solution? All right, step 1. My formula is moles over liters. So I have to take my grams of sodium hydroxide and I have to convert into the mole, where 1 mole is the molar mass of the compound. All right, and the molar mass of sodium hydroxide is 40 grams. So 2.5 divided by 40 in my calculator gives me 0.0625 moles of sodium hydroxide. Now, it tells me that my final volume was in fact 98. So this is the volume I'm going to use. All right, so I'm going to take my moles, 0.0625. I'm going to divide it by 98 milliliters, which is going to be 0.098 liters. So that is going to give me a molarity of 0.638 molar sodium hydroxide.